and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on electrolysis of some selected aqueous solutions. In our last lesson, we learned about how the nature of specific ions has an effect on the electrolysis of aqueous solutions. We discussed the electrochemical series and that ions that are higher in this series are more reactive than ions that are lower in this series. However, we also learned that the ions that are lower in the electrochemical series are discharged before or in preference to ions that are above them. In the aqueous solution of dilute sulfuric acid and sodium hydroxide, we saw that the lower ions got discharged in preference to the higher ions. In today's lesson, we are going to look at how the concentration of ions affects the electrolysis of dilute and concentrated solutions of sodium chloride. We will study what happens during the half reactions as well as the whole reaction. Let us begin. As we learned in our last lesson, the ions that are lower in the electrochemical series will typically get discharged before those that are higher. However, what if an electrolyte has more ions that are higher on the electrochemical series than ions that are lower on the series? The higher ions will get discharged before the lower ions or in preference to them. Let us look at an example. A solution of sodium chloride in water has two types of anions, the chloride ions and the hydroxide ions. Even though the hydroxide ions are lower on the electrochemical series, there is a higher concentration of chloride ions. This means that the chloride ions will be discharged in preference to the hydroxide ions. Students, let us do an activity. Define what it means to have preferential discharge.
Students, let's get ready. begin. Time's up! Let's get back to our lesson.
Welcome back, students. Were you able to define preferential discharge? You were right to say that it is the order in which ions are discharged in electrolysis. Let us look at an example of this. A concentrated solution of sodium chloride has sodium plus ions, chloride ions, hydrogen plus ions, and hydroxide ions. The concentration of hydrogen plus ions and hydroxide ions is very small in this solution. Once the potential difference between the cathodes is established, the sodium plus ions and hydrogen plus ions are attracted to the cathode, and chloride ions and hydroxide ions are attracted to the anode. The hydrogen plus ions are discharged from the cathode in preference to the sodium plus ions At the anode, the chlorine ions are discharged in preference to the hydroxide ions because their concentration is very high. In this video, you can see that in a concentrated solution of sodium chloride, hydrogen gas is being produced at the cathode and chlorine gas is being produced at the anode. Students, let us do another activity. Please write the half-cell reactions for a concentrated solution of sodium chloride.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to write the half-cell reactions? Your cathode or reduction reaction should look like this. Your anode of oxidation reaction should look like this. If you answered both of those correctly, great job! The overall reaction for the solution looks like this. Students, have a look at this image. It shows what this reaction would look like in a cell. Since the sodium plus ions and the hydroxide ions remain in the solution, the solution yields sodium hydroxide, as you can see here. Let us now look at the electrolysis of dilute sodium chloride solution. But first, students, what is a dilute solution? A dilute solution contains a lesser amount of dissolved solutes. Dilute sodium chloride solution also contains sodium plus ions, chloride ions, hydrogen plus ions, and hydroxide ions. During this reaction, sodium plus ions and hydrogen plus ions move towards the cathode. The chloride ions and the hydroxide ions move towards the anode. At the cathode, the hydrogen plus ions are discharged in preference to the sodium plus ions. Since the concentration of the chloride ions is very small in dilute sodium chloride solution, the hydroxide ions are discharged in preference to the chloride ions. The half-cell reactions for a dilute sodium chloride solution look like this. As you can see, this reaction is quite different from the concentrated solution of sodium chloride. The overall reaction looks like this. Let us compare the reaction in a concentrated sodium chloride solution to the reaction in a dilute sodium chloride solution. In a concentrated solution of sodium chloride, the hydroxide ions are discharged from the cathode in preference to the sodium plus ions At the anode, the chlorine ions are discharged in preference to the hydroxide ions because their concentration is also very high. Hydrogen gas is being produced at the cathode, and chlorine gas is being produced at the anode. Whereas in a dilute solution of sodium chloride, the hydrogen plus ions are discharged from the cathode in preference to the sodium plus ions. Since the concentration of the chloride ions is very small in dilute sodium chloride solution, the hydroxide ions are discharged in preference to the chloride ions. Hydrogen gas is being produced at the cathode, and oxygen gas is being produced at the anode. In today's lesson, we learned about different effects that a concentration of ions has on the electrolysis of dilute and concentrated solutions. We discussed how preferential discharge occurs in each circumstance. And we looked at the half cell and overall reaction for both a dilute and concentrated sodium chlorine solution. This brings us to the end of today's lesson. Until next time, thank you, teacher. Thank you, students.